Just so you have some questions about it and make sure you guys are doing it right. So the first one asks about the horizontal and vertical components. There again, we're looking for Vx, we're looking for Vy. Vx, again, is always equal to V times the cosine of the angle that we're looking at, and Vy is always going to be that velocity of the object times the sine of the angle it's launched at to the horizontal. So for Vx, you would have 24 meters per second times the cosine of 30 degrees. And for Vy, you would have 24 meters per second times the sine of 30 degrees. Work that out real easily. Vy is going to be 12 meters per second, and Vx will be 21 meters per second if you get those right in your calculator. Second part is how long is the ball in the air for? So remember, again, the ball is going to go up and come back down. That's all based off Vy. So we can always find the time to go up by taking our initial velocity vertically, Vy, dividing by g. Again, because we're reaching 0 meters per second at the top. So Vy is going to be 12 meters per second. G, again, is 10 meters per second squared. So that's going to be 1.2 seconds to get to the top. And since we're making the assumption we're going to go from ground to simplify the problem, this will be a 2.4 seconds that will spend up in the air. How far will the ball land? Well, that's going to be our dx. How far do we go? Again, that, just like all our other projectile problems, is Vx times t air. So 21 meters per second times 2.4 seconds means that we are going to land 50 meters away with the right number of significant figures. What's the maximum height the ball will rise? So that's where we're looking at the peak. That's where we're concerned about the y-axis. So the y-axis, again, is going to be dy. One of the best ways to find that is using our vf squared minus vi squared over 2g equation, where vf is 0, vi is really vy, and of course we have 2g. So Vy, we know from up here, is 12 meters per second. So we would square that, divided by 2 times 10 meters per second squared. And if we work that all out, we end up with a maximum height in the middle of the motion of 7.2 meters that it travels. So hopefully that helps with question 2.